for it. Hello, everyone. This is our Wildfire Detector. We're Team Xilinx. I'm Manav Bedi. I'm the product manager.
I'm Pierre Quereuil. I'm one of the programmers.
I'm Griffin Bui. I'm another programmer.
And I'm Smiriti Deshpande. I'm the web designer.
So although we all come from diverse backgrounds, we all sort of originally united under the idea of using this experience at AI Camp to create something impactful, to find a sort of greater purpose for technology. Our first ideas for a product included identifying bone fractures, brain tumors, or even the ASL alphabet. But we finally decided on working on a problem that is particularly close to us all as Californians: wildfires. We have all felt in some way or another its devastating effects, so we decided to create a tool to aid in their prevention using artificial intelligence. Our wildfire detector is able to identify fire, smoke, and inflammable vegetation given an image, and is meant, for example, to be used as support for firefighters.
So our journey. I'd like to say our journey is divided obviously between the 3 weeks into 3 parts. The first week, we're really focused on data accumulation. We've found various data sets from Kaggle and a lot of other sites, and also images from Google, and labeled them using Labelbox. We also had to even write a script to change all of these images into JPEGs from different various data tags. Then to ensure quality training data, we went through the images and deleted pixelated ones and made sure that we were training only high quality images to get as much accuracy as possible. Then our second week, we focused on our programming. We began writing scripts, training the algorithm, and we also used YOLO Darknet to train the algorithm. Then we evaluated the algorithm. We looked at the different IOU and confidence level thresholds, and we were able to create various confusion matrices and then choose values that gave us the best results. Finally, our third week was about web design. We designed our original website using NicePage and then modified the HTML and then made this presentation.
During our journey, we made a lot of mistakes. On the right, you can see an image of the algorithm. In the image, the algorithm stacked a bunch of labels. This happened repeatedly. So to combat the stacking labels, we used non-max suppression. One problem we had, though, was the code that we got for the non-max suppression. Every single time, the algorithm would only find one label. So we modified the non-max suppression code, and now it labels multiple different labels. Another problem we had was with our confusion matrix. It was unreliable, but we messed around with the IOU level and the confidence level, and we eventually found a confusion matrix that we liked.
So some lessons that we learned, not burned, during AI Camp is that when working as a team, communication is a key to success. Like, for example, when we were labeling images, we never really specified like a standard for labeling the images. So, that resulted in a lot of confusion when we started training the data. And also another lesson that we learned is that mistakes are going to happen, but as a team, you have to work through them, and that's a sign of success. You have to keep persevering until like the very end. And also AI Camp is a learning experience.
Thank you for listening to our main part of our presentation. Now we're going into our live demo. So Pierre, take it away.
All right. So as Manav mentioned earlier, this camp is not just about AI. We also designed a website in our final week to allow us to display our product, our wildfire detector. We won't show it in its entirety due to time constraints, but feel free to visit it if you want to check it out. So how it works is that we're going to input an image, in this case of a wildfire. And what should happen is it should label the different parts of the image. It should label fire, smoke, and brush, which are going to be the main risks or main signs of risk of wildfire. So here we can see it did it very, very well. It labeled them accurately, and it displays the confidence levels as well. We can see that it was much more confident in the first smoke than the last smoke.
Cool. Now, so we're going to go back and feed an image that has no signs of any fire. And should be this image right here with the clouds and nice scenery. And as shown, it has no signs of wildfire detected and shows that, obviously it's a safe picture. Now we're gonna put in something that can show possible error in our design. So here's a picture of myself. And now if we were to put this into our wildfire detector, it detects me as 96% smoke. Now, Smriti, tell us why this is.
So obviously, Manav is not only 4% human. We only had 3 weeks to pool our data, then label the data, then train the algorithm, and then test and validate it. So obviously, we weren't able to get it as accurate as we would have liked. Also, if an image is really hazy or pixelated, then the algorithm can mix things up and make mistakes.
Cool. Also, if you ever want to learn how to prevent or prepare for any wildfires that might affect you, go to our website, go to the Learn More tab, and then we have 2 links to different .gov sites that will help you out. Thank you for being part of our presentation.
Thank you.
Thanks.
Thank you.
Are you guys talking to PJ and E next?
I was thinking of asking Cal Fire about it and asking and just showing them.
PJ and E lost like billions of dollars, right?
Yeah.
Like, why don't we just talk to them and say, hey, we got this thing, like, can we deploy it somewhere? Maybe they can deploy like certain locations. This is definitely can be usable. Like you can even deploy this using Raspberry Pi. Have you guys heard about that thing? It's a small little computer. You can detect you can attach a camera to it, put it anywhere, drop it anywhere, can detect like wildfire, right? That should be actually completely doable. Yeah. There's no technical difficulty there. There's no technical difficulty there. Yeah.
Yeah.
That's awesome. Yeah.